everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today, we are going to discuss introduction to generating functions, what are the applications of generating functions, and we are also going to see what is meant by sequence and how to apply the sequence and the problems on generating functions and sequences. So first, let us see what is meant by generating function. So here we have a formal definition for the formal generating function. Let us understand here. So let a0, a1, a2, a3, so on up to infinity be the set of real numbers. Let us suppose we are taking some numbers like we are denoting with a0, a1, a2, so on up to infinity. So they are the set of real numbers which denote an. So this an is nothing but where n is equal to 0, 1, 2, 3. So here for the sequence, suppose there exists a one function which is nothing but f of x. So let us suppose here whatever the sequence we have here, so for this sequence we have one function which function its name is f of x. So whose expansion is a series of powers of x. So whose series is a power of x such that we have f of x is equal to, the generating function is a0 x naught, a1 x power 1, a2 x power 2, so on an minus 1 x power n minus 1 up to so on an x power n. So here whatever the sequence we have here, for this sequence we are going to get one generating function. The generating function is always in the form of f of x is equal to a0 x naught plus a1 x power 1 plus a2 x power 2 so on plus an x power n. So for this particular generating function we are getting a series of powers of x, and those series is nothing but a0, a1, a2 so on infinity. So these are the set of some real numbers here where we can consider that up to here an, and this n is nothing but we are going to get the values here n is equal to 0, 1, 2, 3. Now here f of x is equal to, so this generating function we can simplify it as f of x is equal to sigma n equal to 0 to infinity an x power n. So this is a generating equation, generating function formula. So here next, what are the applications of generating functions? So first application is solving counting problems easily. So with the help of this generating function, we can able to solve the counting problems. The counting problems are nothing but, in the last session we have discussed about elementary combinatorics. So where it is nothing but counting the number of objects. And that type of counting objects, counting objects are nothing but what we have used two rules, one is sum rule and the product rule. So these two are the basic building blocks of counting project. So here we can apply this, we can solve this counting problems very easily by using this generating equations. So it will help counting arrangements and also selections, or even the ways to distribute the items without listing all possibilities. Instead of listing all the possibilities, it is very easy to find out what is like generating function by using this arrangements, by using this selections, or even you can distribute the number of ways also. So we turn this counting task into simple equations. Let us consider one example here. So finding how many ways two dice can be rolled to get a sum of 7. So here, if you understand here, we have two dice. Those two dice are here. Let us suppose here I have two dice. So now here two dice can be rolled at a time. So in how many ways you can get a sum of 7 if you can dice 2? So let us suppose here the chances are I need to get sum 7. So either it can be 1 and 6 or 6 and 1 to get a sum. Or it can be 3 and 4, 4 and 3. So here if you observe 2 and 5 and 5 and 2. So these are the possibilities that I can get here to get the sum of 7 when I can roll the two dice at a time. So now how many ways we have? 1, 2, 3, 4, 5, 6. Altogether here I have 6 ways to get a sum of 7 here. So why I am writing here why I am adding all this is, so I may get 1, 6 or 6, 1. I may get 3 or 4, 4 or 3 or 2, 5 or 5, 2. Means I have all the chances to get a sum of 7 whenever I roll the dice, two dice. So that's why in this particular case, you have to do the addition. So that's why we will get the answer here, 6 ways. 6 ways I can get whenever I roll the dice, 2 dice. So this is one counting problem. I can say that this is one of the most important application for the generating function here. And we have another example, another application also, that is solving recurrence relations. So this is also one of the most important application of generating function here. So that is recurrence relations show how each term is depending upon the previous terms, earlier terms. So this recurrence relation, mostly the concept of the recurrence relation means you are going to find out this recurrence relation based upon the previous terms, earlier terms. So generating functions turn them into easy to solve equations. Because of this generating function, we can able to solve these problems very easily. And also we have the best example for this is Fibonacci series. As we all know that Fibonacci series is nothing but based upon the previous terms, you are going to get the next term. So that is if you have F0 and F1, you are going to get F2 based upon F0 and F1. So that is called the Fibonacci series here. So let us suppose here we have 1, 1, 2, 3, 5, 8. It can be solved faster with generating functions. So instead of solving, so by using the generating function, you can able to solve it faster. So besides this generating function, we also have the sequence. What is meant by sequences? The things or events which will come one after another. So sequence is nothing but here where it is following one by one. So anything in terms of our subject here, any event or things which can be done, which can be occurring one after another in which one particular order, that is called a sequence. So a sequence is an ordered list of numbers. It can be objects or it can be events also. So whatever it may be here, objects or events or numbers, anything, it will come one after another. It will occur one after another. So example 2, 4, 6 or 8 even numbers. So if you observe here 2 is after 2 we are getting 4, 9, 6 or 8. These are occurring one after another. These numbers are occurring one after another. Now there is an extremely powerful tool in this discrete mathematics used to manipulate these sequences, and that we can call it as it is a generating function. So, and we also have a few formulas to solve this generating function and also to solve the sequence from the generating function. So, first let us see these formulas, then we'll go for the problem solving on generating equations and also sequences. So, here we have altogether 8 formulas. So, first formula generating function is 1 by 1 minus x. So, here the generating expansion is 1 plus x square plus so on. And this one you can express it in the form of a sequence like 1 comma 1 comma 1 so on. Always you will get 1 only, but because the coefficient of x is here, always whatever the power it is, you will get always 1 only. So the next one is 1 by 1 plus x. So here, if you observe here, 1 by 1 minus x means you'll always get in the sequence positive. Even in the expansion also, you'll get positive. But if it is 1 by 1 plus x, just opposite to this. In the expansion, you will get alternately minus. So that is 1 by 1 minus x plus x square minus x cube so on. 1 comma minus 1, 1 comma minus 1 so on. So next we have 1 by 1 minus x whole square. So this is the formula, the expansion of this generating equation is 1 plus 2x plus 3x square plus 4x cube, so on. So and the sequence is 1, 2, 3, 4. And the next one is 1 by 1 plus x whole square. So here this for this 3 and 4, the just difference is here plus and minus. So if at all if it is minus, you are not getting any negative in the expansion or in the sequence. If it is plus here, you are going to get here negative in the expansion as well as in the sequence. Now here just opposite to this here 1 minus 2x plus 3x square minus 4x. The terms are same here, only the additions that is symbol, the negative symbol or positive symbols are different here. Now we also have the fifth one, 1 plus x by 1 minus x whole cube. So here for this expansion is 1 plus 4x plus 9x square plus 16x cube. So for this here 1, 4, 9, 16. This is the like squares of this numbers. So you'll get the sequence in terms of this. Next we have 1 plus x whole power n, which is nothing but n and c naught x naught, nc1 x1, nc2 x2 so on. So that is nothing but you will get A0, A1, A2. This is a sequence of this particular equation. Now we also have here that is N0, N1, and this A0 is for 1 by 1 minus x, as we have here in terms of x we have minus u. So A0 plus A1x plus A2x square plus A3x cube so on. And the sequence here is A0, A1, A2 so on. And the last one is here, the last formula e power x. So 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial. So here you will get the sequence 1 comma 1 by 1, 1 by 2, 1 by 3 so on. So like these are the formulas that we have here whenever we are solving the problems, if they ask the question here sequence from the generating equation, you have to get the sequence. Suppose if the sequence is given, you need to find out the equation. So from the sequence, so you have to reverse order. From the sequence, you have to find out this generating function. So if this generating formula is there, you have to expand it and you need to get the answer like this. So these are the formulas that we will be using while solving generating functions and also finding out the sequence. So let us see the problem here. So finding the generating function for the following sequence. So here how to solve the problem is, given sequences, so here given sequence is 1, 2, 3, 4, so on. So now we know that the formula is here what? F of x is equal to A0 x0, A1 x1, A2 x2, so on. So now here, this is, so let us suppose 1 and this is 2. Comparing 1 and 2. So we can say that A0 is equal to 1, A1 is equal to 2, A2 is equal to 3, A3 is equal to 4. So by using this, substitute these A0, A1. So that is nothing but here, you have to substitute these values in this equation 1. So that you will get here f of x is equal to, so just substitute the above values in 1. So here then you will get A0 is nothing but what? 1 into x0. So A1 is 2, 2 into x1. So plus A2 is nothing but 3, 3 into x square plus 4 into x cube, so on. So here if you observe, so 1 into x0 is nothing but what here? X power 0 is 1, 1. 1 plus 2x plus 3x square plus 4x cube, so on. So now here in the previous formulas, so whatever you have like 1 plus 2x plus 3x square plus 4x. So what is the generating equation we have here is, so what is the 1 plus 2x, right? So here 1 plus 2x plus 3x square plus 4x cube. So for this, from the sequence we got this one, and from this expansion, what is the generating equation we can write is 1 by 1 minus x power square. So that is 1 by 1 minus x square. This is the generating equation, or even you can write it as 1 minus x whole power minus 2. So this is like how you need to solve it from the sequence, the generating function. Now we also have here the second one. So given sequences, 1, minus 2, 3, minus 4. So on, this is equation 1. Now we know that f of x is equal to A0 x0, A1 x power 1, A2 x power 2, A3 x power 3, so on. So here, just this is consider it as equation 2. Compare 1 and 2 so that we can write it as A0 is equal to 1, A1 equal to minus 2, A2 equal to 3, a3 equal to minus 4. Now substitute the above values in equation 2. So then you will get f of x is equal to 1 into x naught plus minus 2 into x power 1 plus 3 into x power 2 minus 4 into x cube plus so on. So now you will get here x power 0 is 1. So if x power 0 is 1, then you will get 1 into 1 is 1 only. Now minus 2 into x, which is nothing but minus 2x plus 3x square minus 4x cube, so on. So now from this expansion, how you can write the generating equation is, so just here if you observe, 1 minus 2x plus 3x square minus 4x cube, that is fourth one here, 1 plus x whole square, 1 by 1 plus x whole square. So the generating function is 1 by 1 plus x whole square, which is nothing but 1 plus x whole power minus 2. So this is the generating function you will get from the given sequence. So next we have third problem. Find the generating function for the following sequence here. So as usual here, given sequence, so 0, 1, 2, 3, 4, so on. So this is equation 1. And we know that here f of x is equal to a naught x naught a1 x power 1 plus a2 x power 2 plus a3 x power 3. So this is equation 2. So now here, so comparing 1 and 2 here, so we will get a naught is equal to 0, a1 is equal to 1, a2 is equal to 2, a3 is equal to 3. So this is what a naught is a1, a2, a3, a4 also we have 4. So just substitute here in equation 2. So then you will get f of x is equal to a naught is 0, 0 into x power 0, and a1 is what 1, 1 into x power 1 plus a2 is 2, 2 into x power 2 plus 3 into x power 3 plus 4 into x power 4, so on. So now 0 into x power 0, x power 0 is 1, but it is 1 into 0 is 0. So you will get here 0 plus x plus 2x square plus 3x cube plus 4x power 4, so on. So 0 will not consider, then you will get here only x plus 2x square plus 3x cube plus 4x power 4. Now just observe here in the previous slide whether we have the formula regarding this here. So we don't have here. Why? Because we have starting is 1, but then the answer you got x. So now we'll not get the answer here. But what we have to do is just take x common here, then you will get 1 plus 2x plus 3x square plus 4x cube, so on. So then we have the formula, that is x into 1 by 1 minus x whole power 2, which is nothing but x into 1 minus x whole power minus 2. So this is the final answer, which is the generating function from the given sequence. And we also have here, find the generating function for the following sequence. Just it is vice versa here. So here we have 0. Same thing here given 0, 1, minus 2, 3, minus 4, so on. And we know that f of x is equal to a naught x naught plus a1 x power 1, a2 x power 2, a3 x power 3 plus a4 x power 4 plus so on. So now here what we are doing is 1 and 2. We are just comparing 1 and 2. Then we can say that a naught equal to 0, a1 is equal to 1, a2 equal to minus 2, a3 equal to 3, a4 equal to minus 4. So now here, if you substitute these values in equation 2, then you will get here f of x is equal to 0 into x power 0 plus 1 into x power 1 plus minus 2 into x power 2 plus a3 is what 3 into x cube plus minus 4 into x power 4 plus so on. So here as usual same thing here, as we'll get 0 here, so we'll just remove it and we can write it as 1 plus, so even it is not, we can write here 1 into x is what? X. So you can write directly x minus 2x square plus 3x cube plus, not plus, here we'll have minus 4x cube, so on. So as usual here in the formula we don't have a starting with x, it is starting with 1 only. So just take x common so that I'll get 1 as a starting point. Here 1 is 1 minus 2x plus 3x square minus 4x cube. So as we have here 4x power 4. So on. So here x into 1 by 1 minus x, 1 plus x whole power 2, which is nothing but x into 1 minus x whole 1 plus x whole power minus 2. So these are the few problems that by using the sequence how we can generate the generating functions. So then we also have the few problems on sequence, that is nothing but the generating function will be given, based on the generating function how to find out the sequence. So here given generating function, given generating function is 3 plus x whole cube. So we know that the formula here is 1 plus x whole power n is equal to, so sigma n is equal to 0 to infinity NCR x power r. So this is the formula here. So then if you observe here n is equal to 3 and from the given, and x is equal to, so you have to write x is equal to 3, but if you have to take common 3, if you take common then you'll get x is equal to x by 3. So then you just write down here in the formula here. So 3 common, 1 plus x by 3 whole cube is equal to, so then you'll get the formula here. So AC naught, so here NC naught. So 3C naught x power n. What is x here? So 3C naught into 1 power n, and we'll get here x by 3 power 0. And 3C1 n minus 1 x power 3 1. So in the same way 3C2 1 power n minus 2. So as we have x power r, so that's why we are writing here x power. So next we'll have x by 3 2. So plus 3C3 1 power n minus 3 x by 3 whole power 3. So now if you observe here, so here you got, you are just expanding this one. So 27. So 3C0 is what here? So you'll get here 3C0 is 1 only. So 1 into 1 power n. So which is nothing but you'll get 1 power n is equal to 3 here. Just you have to substitute here 3 also, 1 power 3. So plus 3C1. 3C1 is nothing but here 3. 1 power n minus 1, which is nothing but here 1 power n minus 1 is 3 minus 1 2. And x by 3 is what? Same. So next you will get 3C2 is 3. And 1 power n minus 2, 3 minus 2 is 1. X power x by 3 whole square. So please 3C3 is again 1. 1 power n minus 3 means 1 power 0. You will get. So x by 3 whole cube you will get. So now here, so now what we will be doing is we'll just simplify it here. So then we'll get 27 into, so 3, 1 into 1 power 3 is nothing but you'll get only 1 plus, so 3 will get cancelled, then you'll get x here. So then if you observe here 3 will get cancelled, another 3 will be remaining here, so which is nothing but x square by 3. So next here x cube by 3, which is nothing but x cube by 27. So just simplify this 27, just release the brackets and simplify, multiply this 27, then you'll get 27 plus 27x plus 27x square, which is nothing but 3 nines are 9x square you will get, and 27 will get cancelled, x cube will remain. So this is like here. So the sequence here you can write it 27 comma 9 comma 1 so on. This is a sequence from the given generating function. So in the same way here, we have another problem. So the sequence you have to find out from the given generating function. So the given generating function here is given 1 by 1 minus x plus 2x cube. So here, how to do it here is same thing here. So 1 plus x whole power. As we know that here 1 by 1 minus x. So we already have here 1 by 1 minus x. So here 1 by given 1 by 1 minus x plus 2x cube. So we already have the formula here 1 by 1 minus x formula. So what is this is 1 plus x square plus x square 1 plus x square so on. So just write down this formula here 1 plus x square plus so on plus 2x cube. So then here you will get 1 plus x plus x square. Here you will get 2x cube and x cube. X cube plus 2x cube is 3x cube plus so on. So now if you observe here, so 1, 1, 1, 3 is a sequence generated from the given function. So in the same way here, we have other question also, which is given generating function here is e power 2x. So we know that e power 2x, here the formula here is e power x we have in the formula, which is nothing but 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. So here we have in place of x 2x. So just write down here. So 1 plus x by 1 factorial we have now. So write down 2x plus 2x square by 2 factorial plus 2x cube by 3 factorial plus so on. So now if you write here 1 plus 2x plus 4x square by 2 factorial, which is nothing but 2. So 8x by, which is nothing but 3 3 is 9. So 3 into 2 into 1, which is nothing but 6 here. So now here if you observe here, so 2 2 is 4. So here you will get 2 3 is 2 4 is. Then you will get 1 comma 2 comma 2 comma 4 4 by 3 so on. So this is a sequence will be generated from the given generating function. So here today what we have discussed in this session is, so first what is meant by generating function, so what are the applications of generating function, what is meant by sequence, and we have already seen the formulas like 1 by 1 minus x, 1 by 1 minus x, 1 plus x whole square. So means how to expand this generating functions and how to get the sequence from the generating function. And we also seen the problems, how to solve the problems from the generating function to get the sequence and how to get the generating function from the sequence. So by this today we'll end the session. Thank you.